Well, welcome back to my messy desk. So what are we doing today? This is a donated UPS, one of three in fact. But this is the better of the three and also the newest. And among the features that this has is USB monitoring. It's a Digitech brand. I think Jaycar sell them. And I'm pretty sure I remember assisting with the install or getting paid to install this exact unit. And it's come back to me, but not for the right reasons, I'm afraid. The owner of this, who was also became a good friend of mine, has since left us, or left this mortal coil, I guess. But this has landed back in my lap. So I'm going to give a quick rundown on the ins and outs of UPSs. I'm not going to do anything fancy with this, like give it a 12 volt output and whatnot. Largely because I have a 12 volt house battery and solar panels, and I've got that wired to low voltage power points in the house. So finding 12 volts is not a problem for me. This will be good though, because my total desk loading on average is only about 300 watts. I think 1100 when my laser printer is warming up, and this is like a capacity of well, it's 1500 VA, but I'm pretty sure it'll handle probably 300 or 400 watts for a little while. So that'll be great. It means I won't lose my work so frequently. So let's get into this thing. I have a screwdriver here, and we'll take some screws out. Alright, so we have the case loosened up. It comes apart like an old, bit like an old AT computer. Now there is what looks like an 18 amp hour gel cell in here. It might even be bigger. Now it's worth noting, if it isn't already obvious, even though this is not plugged into the mains, you probably shouldn't be playing around with stuff like this if you're not aware of the implications of doing so. You could come to a very short end, and I'd rather not you do that. Anyway, the other reason for this is if you accidentally turn this on, you can get mains voltage out of this thing. But unlike a lot of the inverters I see these days, and this is a mains insulated screwdriver as well, so just so you know. A lot of the inverters I see these days are switch mode. This has a big fat transformer, which I like. That probably means I'm going to get a good sine wave out of it as well. But yes, it has a 250 volt coil, 220, 190 volt, and obviously a 0 volt. This is designed for multi-regions. I do notice up the top here, instead of putting one big FET in there, they put a whole bank of them. And they're obviously doing the top and the bottom half of the wave on an NPN and a PNP transistor here. So let's tip that over so we can get a closer look at that. This is it, quite heavy. Okay, let's change our camera angle because we have a new tripod. Now, it looks like they're doing double pole isolation, which I very much appreciate. That's nice, a good safety step. There's our beeper. That looks like an Arduino AT Mega chip, maybe. That might be where all the smarts is happening. I'm not going to peel that chip or that sticker off to find out. But that little 8 megahertz crystal on the side here really does make me think that. Or it might be an AT Tiny 2313 or 2323. I can't remember the part number for those, but there is a long 20-pin AT Tiny chip. Now, okay, we can see now looking at this, it's not an 18 amp hour battery. Let's scoot up a little closer up here. We can see that it's actually two 7 amp hour batteries, of which I have several spares, which is nice. They look in good condition, they're not bulged. We'll check the voltage in a moment. But they are in series, so they're using a 24 volt system by the looks. So that's good. And there's a little bit of smarts over the back here where the USB port is. That looks like an interface chip, and that is running through a lead that runs it all the way back, comes out around here and into the board right next to what I suggest is an Arduino chip. There's a bit of stabilizing circuitry there too. So I suspect that is controlling the beeping, the front panel display, and the USB port on the back, as in all those things connect right near the bus on that. The other thing I'm interested in is high voltage isolation in here. That's one thing I'm not seeing. Normally with these boards you'll find they've actually routed a big gap in the board to create that isolation, and I don't see it. And some of these boards can actually, because somewhere else in the house I have one of these and it's hooked up to the house battery, it does have the potential to create a mains voltage potential across the battery if it's removed. And it also does ground the entire negative of my DC system it ties it to the mains ground, which has caused a few little smoke ups with my soldering iron in the past. So my test board, if we just zoom around over here, my test board here has fuses on each and every output with fuse indicator lights, and there's another 2 more fuses of successive sizes in series with that for that very reason. And I don't overrate the fuses. I'd rather they blow than melt wiring and start fires. So yeah, there's that. It looks like there's a little test header up here too, but we won't be exploring that. I don't like these cables coming so close with no insulation from the transformer under there, but and straight around a sharp corner. I'm a little uncomfortable with that. I might put some more heat shrink on that, just to add some extra insulation to that, or even, as poxy as it might be, a little bit of insulation tape. But yeah, and in any case, let's get the multimeter out and check these batteries. Okay, hopefully I've got everything in frame. I've got my hypodermic needle probes. They're good for poking through insulation, although I don't really need it here. So let's have a look here. Let's see if we can get that. Whoop. Alright, 13.25. That's surprising. I don't think I've ever been given a UPS with a good battery. And 13.32. That's like perfect. They're fully charged. Well, okay, so we're over limit. Let's go up a range here. Alright, let's try 26.5. Alright. I don't even need to change the batteries. That's like a first. So let's put this cover on and put it into service. Now I'm just off looking at one of these other UPSs, just as a little bit of a sidetrack here. Again, using my insulated screwdriver. This battery has also tested to 13 volts. So 2 UPSs with perfect batteries. Now, given that this sticker really means nothing to me, I'm going to peel this off and find out what is actually under these things. This is also a Digitech or Jaycar branded UPS, and this whole circuit here with the front panel looks very familiar. So I wanted to have a close look at what was under that chip, or sticker rather. So hopefully we'll get our focus sorted somewhere about here, and I will get my handy dandy little miniature Victorinox pliers onto the job of the sticker. Alright, so that is a higher CPU, H-A-I-E-R, and it's a HR6P72P4DL, with additional numbers of GK51B and HJ003. The way it's behaving makes it look very much like an Arduino chip. Let's just look that up. Okay, so looking off in the background here, the HR6P series chips, and this is a 72P4DL, is an OTP high performance Harvard type RISC architecture 8-bit MCU. It's a system on a chip using RISC OS, which is a fairly lightweight operating system. That is an Arduino, or at least a higher version of it. It's a system on a chip, pretty much. It's an 8-bit CPU, RAM, everything all in the one unit. Let's just have a look at the data sheet here and find out exactly what's in there. And apparently my internet's a little slow. But yes, more or less that is effectively an 18 mega. The 18 megas are pretty much the same thing, although I think the 18 mega chips are 16-bit. Let's have a look here. Yeah, so it's 128 128 bytes of SRAM, and it's an 8-bit CPU, and the ROM memory is 2K of ROM, and it's 15 bits apparently. The ADCs is 5 times 8-bit, 10 interrupts. It operates at 16 megahertz, although judging by the crystal that they had on the other one, they've got it clocked back to 8 megahertz. But that's fine. Yep, and the timer is 2 by 8 bits and 1 by 16-bit timer. And a UART interface, which probably explains the USB to serial bridge adapter at the back of the unit. Alright, very interesting. So that's the same chip and the same sticker that's on there, and I think the sticker was probably indicating the program file that they'd loaded into the ROM on this. So yeah, very nice little ROM chip. Arduinos, they're hidden in everything, so if you can program them, you can program the world. Okay, so I took another quick little detour to check the battery on the number 3 unit. Now, I also checked that little chip on, or system on a chip. This one doesn't have a system on a chip, it has a much more basic chip. And now, the proof in the pudding here, if I angle this up a little bit when I check my voltage, this one is dead flat. I've never seen a battery so flat. Not a lead acid one anyway. 0.08 volts. It barely classifies as a battery at that charge. But I think what the indicator here is that this is a much more basic design. And the circuit in here, we've got a whole bunch of chips in here, which I think are using power all the time. It does have double pole isolation with the relays up here, but these chips are chewing power all the time, and these are the kind of UPSs that kill batteries all the time. You've only got to leave them sitting for a week or two and your battery's shag. And they also put Chinese batteries in them that have really super thin plates on them. These Diamec ones, if you run them below 10 volts or even down to just 9 volts, it will kill them. The plates will never come back. So yeah, certainly make sure these ones are left plugged in if you're going to leave them for a long time, or put an isolation switch on the battery to turn it off. Now, it warrants noting that the entire supply for my desk comes through this one heavy-duty cable, through the current meter, and through an RCD here, an inline RCD. But because I've been given a whole bunch of extension leads, I might be able to run that down to the floor and then back up again. And of course, I have some safety equipment down here too. So, alright, let's see if we can find a combination of leads that is going to stand up to at least 1500 watts. Alright, so I took a screaming run up Homer Simpson style and just threw it into the corner. Well, actually I had to remove a lot of stuff from the corner first, but it sits nicely in this corner. I need to get some zip ties and get this out of the way, but everything seems to be fairly well in position except for this lead here that needs to really get positioned properly. But it is actually telling us the batteries are at 100%. It's saying hello, Ashen style. And our volts are 249 volts. That's about right. It should be about 240 volts around here. But I have suspected for a while that the voltage is a little high in this end of town. I haven't fired up the workstation yet. And I did find a USB extension cable in all the donated stuff that I got given. And that pops right out here. And that can pop into this hub here. I'll just move my little adapter along and put it in that end port. Anyway, that means I should be able to monitor its status. So, yep, I'm going to come up to some kind of arrangement about this. And yeah, we'll see how it goes and we'll go through the software. Okay, so crucially, when I plugged it in, it drew about 100 watts to start with, then about 60. And the total power usage just dropped off to about 24.8 watts, which is not too bad. And it's worth bearing that the overhead lights here are on the 12 volt system, and there's about 1 meter of LEDs up there, and they pull about 1 amp per meter, and it's right between it. If I switch on a few desk lights, you'll start to see the current come up. So we're pulling about 24 watts on idle, and it reckons the batteries are charged. So let's see what happens when we fire up the workstation. Okay, I found that the RCD, I'd actually underestimated the length the cable needed, and it actually pulled it out of the plug slightly. But very nicely, it's pulling what I would expect, about 350 watts, and that's for my entire 8-channel DVR system with a couple of big heavy PTZs on there. My system, which is now my main workstation, which is powering up, and I think there's a laser printer in that probably is in low power state at the moment. That's okay. Crucially, what I want to see is if my main computer and my cameras will run in a power outage now. That's the bit that I'm most interested in. So we'll let all this boot up and then we'll try it once it's booted. Now I figure I should probably install this before I do a live test, and so I'm going to plug it into the USB port, and I'm going to drop a few things off the desk whilst I'm at it. Yeah, if you're ever looking at sending gifts, these are the kind of things I quite appreciate. This actually has sand directly from Gallipoli, and as a result of a bit of an uproar and some objections, I'm pretty sure they're not allowed to get sand from the beaches of Gallipoli anymore. So yeah, in any case, I've got it plugged in. Let's see how it comes up in Task Manager. Now, quite interestingly, in the upper right hand corner there, I'm noticing it says Windows Load. So there's a little icon there to indicate that it's connected to USB. That's nice. I wonder if it has a Mac load icon, but this looks like it's a pre-arranged LCD screen, so it might only have one logo for that. Well, I'm going through my directory tree to find stuff, and I thought I'd just have a brag about multi-core CPU while I'm at it. But that's beside the point. It doesn't seem to have thrown up any non-functioning hardware flags here, but I don't know where it's coming out. Unless it's a mass storage USB device, but I don't know where it is. It actually isn't coming up anyway. I might have a fish around the Jaycar website and find the drivers. I normally have a look under the USB root hub, I'll find it, but I can't even find it here. So maybe it's coming up like, you know, all my COM ports are accounted for because I have an actual real COM port on this, which is always COM port 1 and an ACP printer port. So yes, those are actual physical hardware on there. They're not USB emulated. So I don't know where it is. Maybe it's a network adapter. I've got a few network adapters up here. None of them are it though. So all right, let's consult the documentation. So sorry for the weird angle on the camera here. I really couldn't be bothered doing screen capture. But this looks like the unit here. It's the 1500 VA unit. And it looks like it is cat number MP5207 if you happen to be looking for one of these things, going for about $350. Well, I think my price was pretty good actually, all things considered. Now usually on here they have something like a download section. So let's have a look over here. Download the manual and the software. I think I'll do both. Okay, let's save our manual, not 2 pictures but 2 documents. Right, and let's get our software here as well. Yep. All right, and I'll put that on my backup server. Let's get that installed and see how it works. All right, so again, I apologize about the lack of proper screen capture, but let's see what's happening. We've just installed the software, and this is the first run. So this wizard is used to configure parameters of the communication and the number cells. Click Next to continue. Alright, so single phase UPS, that would be what we have. We're not doing any 3-phase or anything like that. And it wants a COM port. Well, I guess it's supposed to be set up as a COM port. Let me just check something. Alright, I found the problem. My USB 3 hub is a bit dicky. It does some weird things. I've plugged it into a native port. So we're going to need to go back here, go next again. I think we're going to need to rerun this software from scratch and see if it will detect the COM port. It still reckons it's running. The application is running. Really? Where is it? Ah, there it is, UPS Mart. So exit it. Now let's see if we can run it again. Let's go up a bit here. Will it run? And it's running off in the other screen somewhere. What joy. Okay, I'm going to swear at this a bit and we'll be back. Okay, so I found the pesky little thing, and I used a trick that I haven't had to use since Windows XP. If you have a program in focus and you hit Alt Space, it gives you a context menu. If you then click Move, you can use the arrow keys on the keyboard to move an application back onto the screen. Okay, so we're back into this. Let me try and make the best of a poor camera angle here. Okay, so what do we have here? Now I've plugged it in. I'm going to hit Window X here, and I'm going to go to Device Manager, because we now know that it comes up as a USB to TTL converter, so it probably pops up as a COM port. Well, apparently it's not. It did set it up somewhere, but there's no COM port here. So let's plug and replug and see what happens. Okay, so now it's working. What I actually had to do was select the Mega USB option. I wonder if that's because it's got an 18 Mega Arduino chip driving it. I don't know, but it's telling me what my frequency is here, which was 59.9 Hertz for a minute. Now it's 50 Hertz. That's looking pretty good. Let's turn off my noisy background fan here, and I think I'm going to unplug it. What do you reckon? Should we smoke test this thing? Alright, I'm going to sneak off camera behind here and I'm going to unplug it while we watch this. Keep in mind, this computer is running off the UPS. Right, so now it's making an angry buzz. And it's saying I'm using about 30% load. So that's kind of nice. The software is logging that. And the button on the front shuts the beeper up. That's quite nice. I wonder if it's going to give us, it's giving us 4.5 minutes. It reckons I've got 8.5 minutes runtime. That's certainly enough to do something about the problem. Let's plug it back in. Now that's kind of good. Now, you know, in doing this, I've made another of my projects obsolete. This is my little UPS I made up to switch the modem over to 12 volts when the mains drops. But I think with this, I think it'll shut off after about 8 or 10 minutes or so of the inverter, and I'll still have internet even when the inverter's flat. So it's kind of like double redundancy. That's nice, but everything's working really well. I'm happy with that. And I think that's about all I can do in this video. I've installed a UPS. Wasn't that riveting? How much time did we waste? Something like 15 minutes? I'm guessing. Alright, well, there you go. That's a donated UPS unit. I didn't have to change batteries. It wasn't too hard to install, which is unusual for Digitech stuff. Software is usually pretty hard. And yeah, everything went really to plan. So, quite happy. And because of that donated extension lead, I didn't even have to cram up my desk hub. So yeah, looking pretty good. So yeah, I'm going to leave it at that. In any case, I do have some more complicated videos coming up. I'm doing a radiation survey meter that's involving a bunch of things like building a Geiger counter from scratch, playing with Geiger tubes, interfacing that with a Raspberry Pi, GPS modules, lots of cool stuff coming up. But it's taking some time, and you know, I've got to kind of earn a living as best I can with MS as well. And you probably noticed in some of my soldering videos, this hand has not been, lefty's not been the steadiest. I've had some troubles with the nerves, and I suspect probably some demyelination in that arm. So, you know, I'm not getting paid for the videos, so you guys are probably going to have to wait. But certainly hit me up if there's anything you want to see, and I'll do my best to make it happen. A little hint for another video that's coming up that I need to do a lot more research on is that if you've seen my donation videos, you will have seen the Microprofessor MPF1 Z80 trainer unit. I'm definitely going to try some machine language on that, but I've got to catch up to speed with a whole new programming language. So yeah, that'll be interesting. In any case, yeah, we'll see you in the next video. I don't know if this was enjoyable, but I guess give me a thumbs up or a thumbs down or whatever you want. I'm probably going to ignore it anyway. The comments, on the other hand, I will pay attention to, at least most of the positive ones. The negative ones I'm not going to approve. So yeah, I'll see you all later.